As you can see guys, our packeting program using manual guide eye is working according to our drawing. That's what we want. So guys, thank you for watching on this tutorial video. I hope you like it, and if you think this video is worth sharing, so you can share this one with your friends, so that many aspiring to become a machinist are going to know this kind of programming on packeting using manual guide eye. And again guys, thank you so much for tuning in on this tutorial. See you next time on my next video. Good day guys, welcome back again to our tutorial, that is Sam's vlog. In today's tutorial, we are going to make packet. So I have this simple drawing that I did. We have 50 by 40 packet, and our datum is at the middle, and we have 4 8mm radius, and we are going to use 12mm end mill. And this is our formula. How are we going to get our spindle speed? The spindle speed is equal to BC times 1000 divide diameter of tool, and then pi, which is 3.14 the value. And we are going to use our BC is 120 meters per minute, and our feed is 0.15 per tooth. And to get our table feed, so this is the formula, number of feet. So our end mill is 4 float, so 4 times 0.15 per tooth, and we are going to multiply it by our RPM, which is the spindle speed. So now this is how I get the spindle speed. S is equals 120 times 1000, so 120,000, and I divide it with the diameter of tool and pi, so the answer is 3184. That's our spindle speed. And guys, our feed rate is 1910, so I just multiply this one with 0.15 times 4 is 0.6 times that's the spindle speed. It will become 1910. So let's do it guys. Our packeting using manual guide eye. Since my machine is running, I'm doing my job. We go to background edit, return to upper folder and input, then going back to our tutorial folder, that one, our new program name, it is packeting, new packeting, that's the name of our folder, and create, then open. So now we have our program name, and since I have guys the registered fixed form, so just press this right soft key, fixed form, and we will select the program start, insert. So we have now this all cancellation just like we have before, and I put in a block and go to fixed form again, and I'm going to select tool start, and I will just alter the tool number. So my tool number for my 12 mil end mill is tool number 64. So we change this one to N64 for my sequence. Tool 64. Our H is 64. Same. D is 64. And we change the name. 12 mm end mill, say carbide. And then we have this again, our G-originated G54. That is very important, the angle of the table, so that you know exactly which angle you are going to, and you are going to position at the middle and 100 millimeter above the job. Let's say I haven't computed yet the spindle speed, so let's do it together. I have 120 times 1000, so 120 times 1000 input. So I have now 120,000. Then I'm going to divide it with my tool diameter, divide 12 and divide again 3.14. Then input, so 3184, which is the one I get, 3184. How we alter 3184, that's our spindle speed. Then we have skip M8, and again we have this is the last line that we need, and then we are going to the cycle. Since the cycle is on our screen, this is the cycle, so press this sub key, and we are going to select, guys, the packeting, and now we will select the packeting wrap, select, and then we are going to input our data on these blanks. So guys, this is called conversational programming, because it's just like you are having conversation with your machine. Okay guys, this box that have a asterisk, it is optional. You can input value, or if you don't want, it's fine. If we are not going to input any value, so we just press input and it will go to the next box. Again, side thickness, we don't want it. So cut depth of radius L, which is the one, this is the one, the step over of your tool. So if we have 12, say we make it 9, so that you have 3 mil step over on each passes of your tool, so you can clean up the bottom of your packet. Let's say make it 9. Then cut depth of your J, axis J, which is your Z. So let's say 1 mil. And guys, your side finish amount, if you want to run your finishing later, you can put, let's say, 0.2, then 0.1 on H, that's the Z, and K is your X and Y all around your packet. And then guys, we are going to compute our feed rate. So to compute the feed, so our formula for table feed is number of teeth times feed per tooth. So we have 4 flutes, so 4 times 0.15 times RPM. So say 0.15 times 4. So we have 0.6. 0.6 times our spindle speed is 3184. 3184. So that's our feed rate, 1910. So we are just going to remove the 0.4, 1910. Then our B, let's say the same, 1910. And our feed down, let's say that 1000. And guys, on this, if you are on this screen, you are just going to use this right key to go to the detail. So press this one, and then we have a choice if we want up cut or down cut. So we are going to select the down cut. So just input and clearance of radius B, 1 mil is fine, and clearance of axis, so it's like your, if you are drilling, that's your R. Retract value, 10 mil is fine. Approach motion, we have a selection of 2 axis or 3 axis. You just go for 2 axis. And if you want straight, it will just go down. You have straight, but since we have a selection of helical, so we can go for helical. This is nice, helical. And we are going to change, this is the helical angle. Let's say we try it 88-degree angle, and the helical radius is, let's say we put 10 mil, and helical feed say 500. And we are going to insert milling figure. So we have now the XY square concave, and we have the XY circle concave, and another one is XY track concave, and the X and Y pre-concave figure. So if you have the coordinates of each endpoints of your packet, so you can use this one. But since for now guys, we will use the XY square concave, we are going to select that one, select, and then figure type, concave, then input, and we will ask you base position. So our base position is 0, top of the job, and the height of your packet, let's say -10, and center point of X, let's say X0, that's our datum, and also center point of your Y, so 0 again, and length for X-axis, which is 50 millimeter, we put 50, and length of your Y-axis, which is 40 mil, 40, and the corner radius, so this is, we have 8 mil radius, we put 8, and our angle is, say, just 0. Then we completed all the boxes, and you go insert, okay, and then we go to fix form again, and we are going to select tall end. So guys, so we have now our wrapping packeting. Since guys, we have our packeting wrapping, so if we want to add a finishing tool, so we can just copy this one, copy, and then we are just going to paste, make this one M30, and we delete this last and block, and then we are going to change it to 63, so 63, 863, D63, and we are going to alter this one to 10 mm, 10, and we need to change our spindle speed. So we are going to use again the same DC, 120 times 1000, so 120,000 divide 3.14 divide 10, and then input. So that's our spindle speed, and we are going to delete this wrapping pocketing wrap, delete that one, but we are not going to delete the figure. And then we go to pocket cycle, and we are going to select the pocket bottom finish, select, and then bottom thickness, so we can leave it blank, input, 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 and then cut depth of radius L, that one is 7, and then we are going to compute our fit rate. Since this one is our finishing, we can make this one a little bit slow. Let's say we are going to use 0.1 speed per tooth, so 0.1 times 4, we have 4 flute, so 0.4, and our spindle speed is 0.4 times 3821, so that's our feed, 1528. So let's say we make that one, let's say 1.5, and this one also is 1.5, and our feed down is 1000. And then we go to the detail, we just leave this one the same, and insert, and we are not going to make y square concave because we have this one, so we just press cancel, and now we have our finishing bottom pocket. So we are just going to run this one in simulation later on if my job is done, so that we can use the simulation. And also guys, I forgot to put our blank, so to put a blank, go to start and select blank, select, and the size of our blank is, let's say the outside is 70, and the length D is 60, and the height same, that one is 20, and our datum is at the middle, so half of 70 is 35, and this half of our 60 is 30. Let's say put 1 mil on work origin set and insert. So guys, we have now our pocketing program. We just need to run it in simulation so that we can see if our pocketing program is going to work. Okay, see you guys later. Okay guys, let's see if our pocketing program is going to work according to plan. Go to simulation, start. So guys, it is working, but if you can see, there is a mark, so meaning that one is not cleaning up. So we need to change our step over. So we can make this one small, let's say 8 mil, and we try it again. Simulation, start. It's working, guys. And also our finishing, we need to change this one. You can make this one 6 mil, or to have a good view, we can rotate X and Y. Okay, let it small, and we can start again. As you can see, guys, our packeting program using manual guide eye is working according to our drawing. That's what we want. So guys, thank you for watching on this tutorial video. I hope you like it, and if you think this video is worth sharing, so you can share this one with your friends, so that many aspiring to become a machinist are going to know this kind of programming on packeting using manual guide eye. And again, guys, thank you so much for tuning in on this tutorial. See you next time on my next video.